All right, folks, today we are going to begin with our vectors masterclass. Okay, so vectors is undeniably one of the hardest topics in JC math simply because some people are not familiar with the content and some people are not familiar to the types of questions that can come out for vectors. I can assure you and tell you that vectors in JC math need to achieve three things in order to do well for this topic. Number one, you need to do well in your conceptual understanding of this topic. So which means I'll teach you how to see the big picture of what vectors are mainly about in JC math. Okay, and some of you, the conceptual understanding is not really satisfactory lah. That's why. Okay, then so what I'm going to do is that I'm going to do a layer of distillation. Okay, I'm going to go and break this down into very macro parts. So I'm going to break it down into like 3 to 5 parts, and at the start for the foundation, I'm going to go like very slowly, such that each of you can build a very solid foundation that you will need before you can even do well in this kind of chapters and start practice questions. Okay, so the next thing that I like to talk about for vectors is that you all need to do visualization. Visualization meaning that your sometimes 3D space may not be easily recognized for you all. So I think that sometimes visualization is a skill, but it's not so important. Because what I'm going to do in the later part of this vectors is I'm going to teach you a special way of how to visualize things. Okay. Then the last one is, of course, practicing questions and how must I be able to identify the question types. I must also tell you that when the question says this, what do you get out of it? And what is the implication the question is trying to tell you? Okay, so without further ado, let's start our vectors masterclass. So the section 1 of the vectors masterclass is going to be on basic vectors. Let's begin with section 1. It's going to be on basic vectors. So this is the solid foundation of vectors that you all need to grasp, because at the later parts, that like things like projection vector or even applications with lines and planes, these are going to get increasingly hard if you don't do it from the foundation, right? It's like how you say the foundation is the stepping stone to success or building, right? You have heard of the Chinese phrase, right? Okay. So anyway, let's begin now. Okay, so first, this is the overview of the success criteria for vectors. Okay, so first thing I'm going to cover is the scalar multiple as well as vector addition and subtraction. Because this is what you learn in O levels. Vector addition and subtraction is not so important, but what's more important is the scalar multiple, because later on identifying the scalar multiple is going to be a very important skill for other topics. Okay, next thing, number 2, I'm going to talk about this thing called the unit vector. Some people, when they learn unit vector, they get very easily confused, but actually it is just one very simple concept. Later on, I'll talk about it. Okay, then after that, I'm going to use ratio theorem as a shortcut to vector algebra. You can probably simplify this as compared to what I learned O levels. Then only after that, the game will start when I start delving into scalar product and vector product before I even jump to perpendicular vectors and the area of triangles. Okay. So the first thing that I'm going to start is the extreme foundation. You guys should not make this kind of mistake. Okay. The first thing I'm going to start with is the vocabulary of vector notations. So we have vector notations that you must note that as what I drew in green over here. So these what I drew in green, all these represent vectors simply because of this wavy sign symbol over here. So this represents vector A, vector B, vector C. Please remember to put your wavy signs. I hope they all cannot afford to make these kind of mistakes in exams, because it's not worth the 1 mark lah. Then of course all this one is wrong, because A B, C without the wavy sign itself is a number. So please learn how to distinguish vector algebra and number algebra. Okay. Number 2, big letter with arrows. So this is also another way of denoting a vector. But what is the difference between the small letter and the big letter? The big letter usually tells you which point the vector starts and which point the vector ends. So imagine that, let's say, the vector OA. It means it starts from the origin and ends at A and goes on and on. AB, vector AB means it starts from point A and ends at point B. Okay? Then please take note that usually vector OA is going to be denoted by a small a vector in the question. Then after that, the vector OB is going to be denoted by a small letter b. All right? This is what most questions will do. If you don't have the arrows for the big letter vector notations, what is OA? OA without the arrows by itself is considered a line. It can be a line or can be a line segment. So please take note of this. Don't make this kind of mistakes in exam. Not worth the marks. I, J, and K component notation is not very common. It's just like splitting up the vector into three components that are perpendicular to each other, because that you know that this world is in three-dimensional space, okay? And then the last one, column vector for the matrix, is the most common because most questions like to express it in this form. And moreover, when you sum vectors up, or rather when you do cross product, dot product, all these data that come by, right? All of them are expressing it in column vector form. So column vector is most common. So without further ado, then let's move on to the next portion. Okay, so notice that in this topic, I'm going to link it to a lot of geometry. As much as I start talking later on, you have noticed that, oh, okay, the vectors that you learn is all related to the geometry that you learned in secondary school. So vectors is actually a geometrical topic, right? Sometimes it can even be linked to the coordinate geometry that you have learned in additional math when you're taking secondary school O levels. Okay, so let's recap. Now, you see, AB is going to be a very common, very common thing that appears in like vectors or even geometry. Okay, so when you were learning in secondary school, first thing you learn is geometry, right? You learn things like, oh, AB can be a line because it passes through the points A and the point B. And after that, you learn something like what I call the line segment. What is the difference between line segment and line? I will explain to it later, okay? Then later on, you start learning that, oh, okay, lines do not just have a number and a magnitude. It also has a direction, right? Which direction are you going? Is it bidirectional or is it unidirectional? So this is when the word vector comes in to tell you which direction you are going. Then the next one is the magnitude of vector AB. So the magnitude of vector AB, that means that asking you how long is the vector. You want to travel from place A to place B, or rather from your friend's house to your own house. How far do you need to travel? Right. So this is what it means by magnitude. Then after that, the next one is going to be vector. My apologies, I just sneezed. Okay, so vector B minus A. So as you can see, all these here, these are small letter notations. Take note that the small letter notations are meant to represent vectors that start from the origin. So if it's a small vector, letter B, it's going to represent the vector OB. Okay, and likewise our OA is going to represent the vector OA. Okay, then this one is just basically a vector subtraction. So these are the very different ways to go, the many different ways to go and interpret what AB is talking about. And of course, in exams, you need to go and identify whether the question is asking for a vector or number, because let's say it tells you that, oh, okay, AB equals to 5. What can you infer? You look at the first two possibilities. A line doesn't, it's just a line, right? AB is a line, so it couldn't have a number. So the only possibility to go through later is going to be the magnitude of AB, right? Magnitude of AB is the only one that can have a number because it tells you how long the distance of AB is. Okay? Then without further ado, let's recap the vector addition laws. Okay? Vector addition laws, polygon law is an extension of triangle law versus parallelogram law. This one, I need to say something. I need to say that when it comes to parallelogram law, it's only giving two vectors, because you tell me yourself how many sides does parallelogram have. If you have to add three vectors to parallelogram, it won't be a parallelogram anymore, you know. So the only way to add three or more vectors is using a polygon law. This one has been covered in the O levels. I'm not going to talk about it so much. It's just this is like the front of one vector should coincide with the end of another vector, and then this. So let's say this is where the vector starts, and then this is where the vector ends. It's other like taking the shortcut. The red color line is the shortcut, while the purple color line is the long cut. Okay, so this is the main idea. I'm not going to talk so much about it. Now, what's more important here is now the scalar multiple. Okay, this scalar multiple, I'm going to go through very, very slowly because I want you all to have a very solid foundation on what the scalar multiple even means. It's going to be very common in the applications of vectors that come by later. Okay, so now, so imagine that you have a vector A. Okay, imagine that you have a vector A. Then what will happen? The scalar multiple means you are going to the scalar means a number, you know that? So that means you are going to multiply the vector by a number. So let's say, okay, what's the simplest number you can think of now? Maybe one, but one is like a bit ambiguous. So because one later on will get cancelled off, you don't have to really write one. So okay, let's say I got two. Okay, I think of two as a number. Okay. What is going to happen when I multiply the vector A by 2? So a quick analogy for you to imagine is that, oh, okay, imagine if a vector was a punnet of strawberries. Vector A was, let's say, a punnet of strawberries, okay? If I buy one strawberry, if I want one container of strawberry from the supermarket, then you notice that it just gives me one packet of vector A. So, but what if, let's say, I wanted to buy 2 packets of strawberries from the supermarket? You notice that the number of strawberries that I eventually have is going to be 2 times the number of original strawberries that I have to buy, right? So, in other words, it's like saying that, oh, okay, 1 pack of strawberries multiplied by 2 is going to give you 2 packs of strawberries. So, in other words, the same thing for vectors. Vector A, 1 pack of vector A multiplied by 2 is going to give you 2 packs of vector A. So, 2 packs of vector A is that's what I have drawn over here in the red color line, extended red color line. Then, in order to simplify it, because you are adding A with A, is going to be none other than 2 times the vector A. Then you notice that, oh, okay, you see here, because I extended the vector A by 2 times, it obviously means that now, oh, okay, the blue color line is much longer than the short red color line, right? So this means that the scalar number, as you can observe, the scalar multiple is going to extend the magnitude of the vector. But something you have to take note is that it will never ever change a direction. You don't tell me that, oh, okay, you one day you go to the supermarket and buy strawberries, then after that you go and multiply to, oh, okay, exchange for oranges. No such thing, right? So it's the same analogy here. Okay. It's really the same analogy over here for the scalar multiple. Alright, folks, so I'm back. I need to lower down my volume slightly. Okay, so just now I was talking about the scalar multiple, then the magnitude wise. So the scalar multiple is only going to make adjustments to the magnitude, but in no way is it going to change direction, right? Okay. So I want you to imagine magnitude like the number of strawberries inside the punnet. Okay. Later on, when you do unit vector, I will explain why. But for now, just remember because it doesn't change direction. So whenever you do scalar multiple of vector, always remember that they must always be parallel. If A is a scalar multiple of vector A is a scalar multiple of vector B, the straightaway implication that you must have is that the 2 vectors are parallel to each other. Okay? Now, I'm going to go and do this collinearity question phrasing exercise that I want you to do what I want you to do before the next lecture video is that I want you to go and go and try this exercise on your own. Because these are many phrasing types of questions that can be phrased on collinearity or rather testing one concept. Okay. So because collinearity, they are talking about like parallel vectors with a common point, and then after that they will like, oh, okay. So they're asking you like, okay, let's say I have let's say I have an A B over here, right? As you can see, this I'm going to highlight this line yellow. Let's say I have this. So yeah, correct. Let's say I have this line A B over here. Okay. Given all these scenarios, right? Let's say I want to insert a point P. This point P can have 4 possible options based on the different question scenarios. So I want you to go and try this exercise on your own. Where could P possibly lie on? Based on each of the following question statements over here. All these question statements, okay? There can be more, each question statement can have more than one possible choice, so you don't have to be treated to one. You just make as many possible choices as possible. Then after that, when I'm like in the next video, I'm going to go through the answers for this, okay? Now try your best. Like I said, there is more than one possible answer. Where could P possibly lie on? Option 1, option 2, option 3, option 4, or all of the option or all of the options. Can even be like, oh, option 1, option 2, and option 3. Maybe option 1, option 4. Up to you. Just go and do this worksheet. Okay? Thank you very much for your attention. And thank you. Yeah. Have a nice day.